All right, so now we're on to our model problem on the next page that I want you to capture in your notes before you do your check for understanding questions. So the scenario in part A, well, first of all, particle x moves along the positive x-axis so that its position is always given by this function, x of t. Is particle x moving toward the left or the right at time t equals 1? Give a reason for your answer. So this is something that oftentimes confuses students. When I'm asking if you're moving left or right, I have kiddos all the time try to just plug a 1 into this position function. But that'll only give me my concrete position at 1. It will not indicate to me which direction I'm moving. So a big key lever here that wasn't addressed in the first three ideas we talked about is that if we're moving left, what that means is that the velocity of our function is negative at that moment. And if we're moving right, our velocity is positive. This is a big key concept that you learned in physics, so it's important that we apply that to this scenario because it turns out this position function is not going to help me to answer this question. What I need to do is make sure I uncover the velocity function in order to get to the root of this. So position to velocity means take a derivative. Our velocity function is 15t squared minus 18t. Easy power rule here that I can apply. And so then to discover if we're moving left or right at time t equals 1, what I want to do is plug a 1 into this function for velocity, do a little bit of math, 15 minus 18, and get to my velocity of -3, which is great for one reason. -3 is a number that's less than 0. So I can come to the side now and draw my conclusion. I'm moving left at t equals 1 because v of 1 is less than 0. Okay, part B, at time t equals 1, is the speed of the particle increasing or decreasing? Justify your answer. This was covered in our first key levers. So for speed of the particle to be increasing or decreasing, you can make a little note to yourself. Our strategy is going to be to compare velocity and acceleration. If I can do that and gain some insight into the signs of those two functions, I'll be able to draw a conclusion. So let's see, let's recall from part A. V of t was 15t squared minus 18t, which means A of t with more power rule is 30t minus 18. So those functions are really helpful, but remember what I want to do is think critically about what's happening at t equals 1. So I'm going to find v of 1, which I think I just did in the previous problem. That was -3. And a of 1 is going to be 30 times 1 minus 18, or 12. So just a quick note to myself, that -3 value is less than 0, and this 12 is greater than 0. So according to our notes from before, my velocity and acceleration have opposite signs. So I can say at t equals 1, the speed is decreasing because v of 1 and a of 1 have opposite signs. And my work up there supports this conclusion down here. Okay, on to part C. At what time is particle x farthest to the left? So I've gone ahead and written down my original position function here so that I have access to it. But what I want to do before I get into this is annotate farthest to the left. What that means is, can we discover the absolute minimum of this function? Farthest to the right would be absolute maximum. But because I want to know how far left, or the most negative value that my position takes on, that's another way of stating, please find the absolute minimum. So a little bit of a review here from absolute extrema. To find the absolute minimum of a single function, the generic strategy is to find our critical points and our endpoints and to test all of those back into the original function to find the most negative value or the smallest value that our function takes on. Critical points are where the derivative is 0 or undefined. And endpoints are typically given to us, so we just need to make a note of those. In this problem, I noticed that I'm only given one endpoint, a boundary here of 0. I'm not given a maximum endpoint here, so I'm only going to have to test the value of 0. But the critical point I need to go ahead and find. So what did we decide earlier? Our derivative function here was 15t squared minus 18t. And my note says to find the critical points, I should set that equal to 0 or test if it's undefined anywhere. Well, this is a quadratic, so it's not undefined, but it will equal 0 in a couple of places. So let's factor out 3t, and I'm left with 5t minus 6. I set both factors equal to 0, and I solve. It looks like t is equal to 0, and t is equal to 6 over 5. Are my two critical points. Notice that first critical point is also an endpoint, so I would have tested that anyway, but now I'm seeing here that I run into that value again, so I'll make sure that I'm plugging that into the original function to see our position at that time. So to finish this off, I need to see what x of 0 is equal to, and I'm taking this original function, plugging a 0 in, and without much effort, I land at 7. And then I also want to plug in a 6 over 5 and see what happens when I plug in 6/5. That's going to be 5 times 6/5 cubed minus 9 times 6/5 plus 7. And let's see, I'm going to take my calculator out for just a second. 5 times 6/5 to the power of 3 minus 9 times 6/5 to the power of 2 plus 7 is what I have to evaluate here. And I get 67/25, or as a decimal, 2.68. So let me go record that over here. 67/25, or approximately 2.68. Okay, so at my critical values, I have a position of 7 and a position of 2.68. So at what time is the particle farthest to the left? Well, when is my position the least? That's at t equals 6 over 5. And had the question said, when is my particle farthest to the right? I'd be looking for my largest position, and that would be at t equals 0. All right, this last part is where things really get interesting. A second particle y moves along the positive y-axis, so its position is given by this new function, 7t plus 3. At any time t, the origin and the positions of x and y are the vertices of a triangle in quadrant 1. Find the rate of change, that seems important, of the area of that triangle at t equals 1 and show your work. So maybe it will help if we visualize what they're communicating to us here. Here's the first quadrant. What I saw earlier was that I have this particle called x that's moving along the x-axis. So maybe at a given time, he's right here, x, at that red dot. And now in this question, they're introducing another particle who moves along the y-axis up here, represented by the blue dot. At any time, you can see that the origin and those 2 points form a really nice triangle right here, in quadrant 1. What we want to try and do here is uncover the rate of change of the area of that triangle. We've talked about this a lot. When we see that word rate, we think of the word slope. And when we think of slopes in calculus, we know we're being asked about derivatives. So the derivative of area here, symbolically, how about a prime? I want to know what a prime at 1 is in this question. Well, I can't find the derivative of area without first knowing an area formula. So area in terms of this triangle is going to be 1/2 base times height, right? That's how we have found areas of triangles since we were little. The base of my triangle looks like the position of that particle x. So maybe I can rewrite this as 1/2 of x times, well, the height of my particle looks like the position of y. So 1/2 x times y. And then you know what's coming. If I want to find a prime, well, let me take the derivative of this function, this product of two functions. Here's my f, here's my g, thought bubble over here. How do I find the derivative of a product of two functions? Well, I use fig plus gif. So let's see. Well, the derivative of f, remember all these functions are with respect to time. So the derivative of f, 1/2 x, is 1/2 times dx dt. Nice. That's f prime. Times g. Well, g is just y. Nothing fancy there. Plus the derivative of y, that's 1 times dy dt, times f, 1/2 of an x. So I'd love to figure out what's going on at 1. So what I'm going to need to do here is plug a 1 into this function. Let's not forget that dx dt and dy dt just represent derivatives of our two particles or velocities. So I remember in the earlier question that I already uncovered that v of 1 was -3. I think there was another opportunity. Nope, I haven't done this yet, so we'll figure this one out together. I need to know what x of 1 is, because that's going to be what I plug in way down here in a minute for that x. X of 1, let's see, that's going to be 5 times 1 cubed minus 9 times 1 squared plus 7. A little bit of math, that's 5 minus 9 plus 7. I think that's 3. -4 plus 7 is 3. So I've got, let me make sure I make a note, that's the velocity of the x particle up here. That's supposed to be an x, guys, sorry. So I've got some of this information, but let's not forget, I also have a y position now, y of t, and I'm going to really want to know what y of 1 is. So how about 7 times 1 plus 3, or 10? And dy dt, or y prime of this function, well, that's just derivative of 7t plus 3, that's 7. Nowhere for me to plug a 1 in, that's always 7. So let me come down here and start doing some computation. I have 1/2 of the derivative of my x at 1. According to my note up here, that's -3. Multiplied by my y at 1, which I did work off to the other side, is 10. Plus the derivative of y at 1, using my notes up above, that's 7. Times half of my x position at 1 and my x position is 3. Let's see, I do some number crunching. Half of -3 times 10, that's 1.5 times 10, that's negative. I think I get -15 from my first group up there. Plus half of 3 times 7, half of 21, that's 10.5. And the rate of change for my area then is going to be negative, what's -15 plus 10.5? -4.5? And I'm good. Okay guys, so we finished the model problem. Your job now is to do the check your understanding problems. And if you look over at your packet, you're going to want to attempt this matching activity right here where a statement is given and you need to find the symbolic representation of that statement. There are too many letters down here for the 13 statements, so some of those will not be used. They're distractors. And once you attempt that matching, I want you to come down here and try